So for distributing in, we're multiplying into the parentheses. And so when we factor by a GCF, we're just doing the opposite of that. So I'm multiplying, and again, this was on our last test, or the test you guys just took yesterday. So we multiply that in, so 5 times 4 would be 20, and then I add those exponents, a to the 4th, the 5a to the 2nd times the 2a, so that'd be 5 times 2 is 10, and then 2nd, and then the 1st would be the 3rd. And then 5 times -7 is a -35, and then a to the 2nd. And then we just leave it that way, nothing else can go together. That's as simplified as it can get. So if you don't remember factoring by a GCF, we're just doing the opposite of that. So I would give you what's in the red, and I'd want you to write it as the original problem. So we're going to be taking something out of each of the terms. Next one, same idea, just distributing in. So again, we're multiplying in. Multiplying. And so that would be our new version. So again, if you're talking to someone in my algebra class right now, they might even be able to help you with this, the factoring by a GCF. Hopefully it's something they're able to help you with, because they've been doing it for probably almost the past month. And so we're going to be factoring out. So again, not very long notes. I don't even know that we'll do all the examples. Again, this is something you guys learned in algebra, but again, haven't used since then. And also something probably you didn't love when you did it in algebra. Not many people are like, yeah, factoring is my favorite. So it's understandable if it's not something you totally grasped the first time you saw it. So again, what we're trying to do here is hopefully when you guys would see this again, if you took an Algebra 2 class, or had to take like a college algebra class or something like that, or something you're headed towards, hopefully this would help you guys to like kind of have a little bit more background on it. So the greatest common factor is obviously what it sounds like, kind of it is, but obviously greatest common factor, maybe you don't like, that doesn't process what that means. So what we mean by that is common means something they have in common. So the same number and the same variable that can divide into all terms. And I probably should have said, it says the greatest as well, it's the biggest. So we try to find the largest. And so I'll show you guys a little example of that, or just a little example of finding that GCF. Now a GCF is also something you use when we're working with fractions. So the greatest common factor is a number that you can divide out of all of a fraction, like a simplifying a fraction when I can divide out like a 4 out of both numbers. So like for instance, I'll just kind of give us a few numbers to work with here. So let's do 20x to the 2nd, and let's go 15xy, and also 5x to the 3rd. So let's say we're going to find the greatest common factor among all these. So what's the number that would go into, and when I say goes into, it means divides into evenly out of all of those. Yeah, go ahead. 5. So the 5 would be, so if I want to list out our GCF, the 5 would be the largest number that can divide into any of those numbers. So 5 can be divided by 5, 15, 20, they all can be divided by 5. Now what's the largest variable that I could divide out of those? Or variable in power? What would be the largest that I can divide out? What do you think?
X.
Yeah, it's just gonna be an x because I can't take more than I have. So I can't say, well, there's an x to the third that's common or that's there, but I can't like take this one and say like, give me x to the third. It doesn't have it to give. So we're taking out the most possible. So that would be the number the number term we would take out. So when we do this factoring by a GCF, we're gonna find that GCF, and we're gonna write it on the outside. So outside the parentheses, so if you guys see I have like little parentheses here, we're gonna find that GCF. And we're gonna divide it out of all terms. And then our second step is basically inside the parentheses, we're just gonna leave whatever's left over once we've divided that out. So kind of like if I said everyone needs to contribute $5 to our class party, and if you have a ton, obviously you'd still have some money left. So we have to talk about like the leftovers. So we're going to leave the leftovers inside the parentheses. And I'll show you guys what that looks like. Again, this is something that's not brand new to you, but again, at the same time, it's not like something that comes up just like when you're at the grocery store. Like factoring is one of those weird things that only gets used as we're going up in further math. Like it's not like something that's useful at the grocery store. So I'm gonna tell you guys that right now. But at the same time, if you need to take classes above algebra, obviously you're gonna need it. So we need to make sure that we're just like giving you that option, problem solving. So, and you don't have to write this out to the side. I'm gonna list the GCF and talk about it. But then I'm just going to put it on the outside of the parentheses. But thinking about what the GCF is, and I actually picked something that was very similar to the one we just did. So 15 and 25, the largest number that goes into that would be 5. And then the variable would be x. So finding the GCF is important, but I'm going to show that by putting it on the outside of the parentheses. Now, when my students are struggling with this in algebra, a lot of times I'll say, show what you're doing, like kind of show your steps. And what I mean by that is if I show I'm basically dividing a 5x out of these. And we just did when we do this in algebra, we had just done the chapter on like all the exponent rules, so it makes sense to them to look at it that way. Or it hopefully makes more sense. So 15 over 5 would be 3. X to the second over x would just be a single x, because it's 2 minus 1. Minus 25 over 5 would just be 5, and then these x's just cancel. So our factored version is this. Now, if you're trying to check to see if you did it correctly, you can always talk about going back and kind of doing like we did with the warm-up and distributing back in, because the two are interchangeable. It's kind of like saying I ate 2 out of 4 pieces of pizza or I ate 1/2. They're the same thing. It's just 2 different ways to write it. Okay? So we're going to flip the page over. Like I said, we're probably just going to run through a few of these, or probably can get through most of them, but I'll probably pick and choose a few to maybe skip. But we'll go through some practice with it, and then you guys will have a worksheet, not this bookwork. And for the worksheet, I found it's kind of on the long side, so I'll give you like half of it to do. Like odds or evens. Okay. But this is setting the groundwork for other types of factoring we're going to do. And I debated kind of putting all the factoring in one chapter or one section, and then I decided against that just in terms of like our comfort level with this, maybe knowing it's a tougher idea. So, for example 3 here. I don't know what happened to it. There's like 2 example 3s. Examples 1 and 2 are missing. But anyway, what goes into both of these? What would be my GCF? what is it? 2, and then what variable? 2c. So we're going to take a 2c out of each. And again, you don't have to show the divide step, but I like doing that just to kind of visualize what's happening. So 14 over 2 would be 7. The 2's would cancel. 2 over 2 will cancel. And I'll have c to the second over c to the first, so that'll just be c. Now, if you ever try to take more than it has, you might end up with a negative exponent. So just ahead, you don't want negative. All right, so that's kind of our run-of-the-mill question. Whereas this next one is kind of almost kind of, let's go super tough all of a sudden. So we kind of like didn't really ease into that. So we have to look at the 3 terms and what goes into all of them. Now careful here. We have to make sure we find the greatest common factor. Not just a common factor, but the biggest number that goes into all 3. So before you blurt out an answer, be careful. Think if there's maybe a bigger number. And I'm saying that because there's multiple numbers that can go into those 3. Yep. 6. Yep, I think 6 is the greatest number. Because if you're not great at finding these factors, I usually start with the smallest number and work with that. So 12, I know that, like if you're not great at this is, I show my algebra students, like 1 and 12, 2 and 6, 3 and 4. So I look at this list, but then I say, oh, 12 goes into 24, but 12 doesn't go into 30. So I skip that one, that doesn't work. Then I go to the next largest number, 6, and 6 goes into all 3. So 6 is gonna come out. How about variables? Yep.
X and Y.
Both x and y can come out because they all have an x and y. Again, the divide by step isn't necessary to write out, but I like doing it just to show what I'm up to. Now this first one, the x and y's just get to cancel. So 12 over 6 would just be 2. 24 over 6 would be 4. The x's would cancel, I'd be left with a y. Negative 30 over 6 is a negative 5. And then I have a single x and a y to the third left. So sometimes students ask, why do we learn exponent rules? I'll say for this, then they'll ask me, it's like a, like ongoing question, well, why do we learn factoring? And we haven't yet found out why exactly we learn factoring. So it's something so much to look forward to as you move on in math. All right, the next one's kind of a strange one, so I wanted to mention that one. And like I said, we might, I definitely want to do 5 and 6, and then let's see where we're at. The last couple, I guess, are really fast too. We can probably finish this. All right, so negative 2 and negative 7 are strange, or 5 is strange because of the negative 2 and 7. So if you notice, there's no variable that's common. The one has a y, the other one doesn't. But what do they have in common? Yeah?
A negative sign.
Not a negative sign. I thought you said negative 7 at first. No, negative sign, yes. They have a negative sign in common. So if I wanted to take that negative sign out, I could take out a negative, or like a negative 1 is essentially what I'm dividing out. So I'm going to divide out that negative 1. And I think we'll do odds for this. So just the odds right there. So we're going to take out a negative 1, and all it's going to do is change those signs. So this one seems super, not useful. But at the same time, it's still important to kind of point out that it is possible to just take out a sign like that or a negative 1, and that's perfectly fine. The next one gives the most issues to students because of something that ends up happening in this case. Turtle's coming for you. I thought he was headed for the door and then he changed his mind. All right. So between these 3, what number is common? 2. Okay. How about variables? X and Y. We're gonna divide that 2xy out of all the terms. So our 10 over 2 would be 5. X to the third over x to the first would be x to the second. And then 2 over 1 would be just 1. 8 over 2 would be 4. X. And the second. And now this is the tough part of this one. What's going to be left when I have 2x to the second over 2xy over 2xy? What's there? Yeah, we want to write that as a plus 1. If you don't, and you just say, oh, it cancels out, it's gone. If you cancel it out, when we talk about like foiling it back in, you've just lost a whole term. So that term is missing and we need it. So we need to make sure we have all the terms. So the one's just kind of a placeholder. Let's finish up with the last two. They're really short, and then you guys will have the rest of the time to get working. And then, like I said, you guys can work on homework, which will be the odds on this worksheet, which is not what's listed there. Okay. So our next one, again, kind of a strange one. What goes into this one? Just a 1, yeah. Because there's no variable. 7 and 9 don't have a common factor, but 1 always goes into anything. You could technically take out a negative 1, but I usually like that first term being positive. So I would probably just take out a positive 1, so nothing happens. So you're probably like, that was the lamest problem ever. Or you can say there's not factorable, like you can't take anything out. But technically we can always take out a 1. So if you had done it this way, it's not wrong, it just probably isn't any more useful. And then our last one, what goes into all the terms? 5. How about a variable? No, this one doesn't have a variable, so we don't have to worry about that. So we're just left with this when we're done. Okay? So we're going to do worksheet, odds. And again, still not trying to take up a ton of your time, but at the same time, I want to give you some learning to do. So just be aware, if you guys finish your worksheet, feel free to work on other class materials, missing work, anything like that. Use your time wisely, please. Brody, I'll send them back with these guys here. Again, we're just doing the odds, which is just like a column of the worksheet. Okay? And feel free to ask each other for help or me. I bet it sounds like some of you guys really